Hello, everyone. This is Mr. Honig. I'm going to be talking to you guys today about scaled copies, otherwise known as scale models, and something known as scale factors. So when we think of something that is a scale copy or a scale model, you may have heard that a little bit more frequently. Scale model is taking something that we know typically is very large and condensing it all to make it very small. So think about a scale car, model houses. This is probably something a little bit more relevant to you. We could also take something that's very, very small. So think about scale models of atoms, which are very, very small. We can't see them with our naked eye, and we actually scale them up to make them bigger. So that's what this unit is going to get you into, and understanding what a scale copy actually is. The book definition of a scale copy is it's a figure that is geometrically similar to the original figure. So what it means is everything about it, they're both the same shape, they're just different sizes, okay? So here's how we're gonna get to that. I have an original picture here, and I'm gonna play with some of these sliders that you guys see, and we have to answer which ones of these actually make a scale copy of the original portrait. So here's my original portrait right here. I'm gonna jump in. And when I want a scale copy, it is a scale copy when every single time I move this slider, the picture is a replica of the original, okay? So as I move sliders A and B, are they always an exact replica or the same shape, just different sizes of the original photo? The answer obviously would be no, because as you notice, in slide A and slide B, they shrink and squash the original photo, okay? So what that's doing is that's actually here, if we want to talk about this in height, okay? It's actually shrinking the height one dimension in slider B, and in slider A, it's shrinking the base or the width, if you take a look at that, okay? So it's shrinking the figure, but it's squashing it, and that's something that does not create the scale model, okay? If I look at slider C, that one, although it gets very small, it actually does create a scale model because the figure is always the same figure of the original. It's just a little smaller. Same thing with D. It's just a little bit bigger, but it is the same shape, okay? Slider E, would this be a scale model? No, because although it's a parallelogram, it is not the same shape as the original portrait there, okay? So that's a brief overview of what a scale model actually is. Now, the second piece to this is to know what a scale factor is. So all a scale factor is, we talked about a scale model is a model of something that was big and we made small, or was small, we made big. A scale factor is the actual number that increases or decreases that shape. So a lot of times we are going to use the scale factor, and we are going to use this with multiplication, okay? So here's my example. We're gonna look up here. We'll look at shape A here, make it easy, okay? And shape A, they want us to take figure A and use a scale factor of 3, which means everything about this shape here is going to get bigger by a factor of 3. And what that means is we're going to multiply all of our sides by 3. So if my original base down here is 3 units, I'm going to take that 3 units and multiply it by my scale factor of 3. So now I no longer have a base of 3, I have a base of 9. I'm going to come down here, I'm going to draw it all the way at the bottom. I'm going to come 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go, okay? Now I look at the height of my figure, and when I do any of these pictures, I only want to be taking them distance as vertical or horizontals, okay? Those I can actually count. Never on an angle, because we actually don't know that distance without a little bit more math. Something known as the Pythagorean theorem, which is for a different time, okay? So again, now I have a height of 3, so again, I actually know that answer. 3 times 3 gives me that new height of 9. So I count up 9 spaces. I'm going to place a dot there, and then I'll draw straight down. Okay, so there's my new height. I look at this horizontal distance of 2. So now I'm going to take that scale factor 3 and multiply it by 2. So now my new distance is a distance of 6. Count over 6 spaces. 1, 2, 3, 4, 5, 6. And then all I have to do then is connect these last two. And look what we have. We have an exact scale model of the original figure. So I hope that helps. Okay? You guys are going to be playing around with some of this today in your lesson. So make sure you ask your teacher questions in case that was not as clear as it should have been.